Good afternoon, my dear children. We are learning about the periodic classification of the elements. How many electrons are there in the first, second and third and fourth periods? The number of electrons that can be accommodated in a cell depends on the formula 2n square, where n is the number of the given cell from the nucleus. Here I have written that there are 4 cells K, L, M and N. So suppose this is the first cell. The first cell is known as K. The second cell is known as L. Third cell known as M, and the fourth cell is known as N. How many electrons that the cell can accommodate, it depends upon the formula twice n square. N is the number of the given cell from the nucleus. This one is the 1 number cell. So 2 into 1 square is equal to 2. That means this cell can accommodate only 2 electrons. L, this is the number 2 cell from nucleus. This is the nucleus. This is the nucleus. From nucleus, this is the number 2 cell. So 2 into 2 square is equal to 8. That means this cell can accommodate 8 electrons. The position of an element in the periodic table tells us about its chemical reactivity. The valence electrons determine the kind and number of bonds formed by an element. I will discuss the sentence. The valence electron determines the kind and number of bonds formed by an element. Now you see the sodium. Sodium atomic number is 11. So electronic configuration is 2, 8, 1. That means on the outermost cell it has 1 electron. Similarly, chlorine, the atomic number of chlorine is 17. The electronic configuration is 2, 8, 7. On the outermost cell there are 7 electrons. So the sodium want to donate 1 electron to chlorine to attain the nearest inert gas neon's electronic configuration, and chlorine want to accept 1 electron to attain nearest inert gas argon electronic configuration. So it will be 288 and it will be 28 only. So it is neon, it is argon. Now it will lose 1 electron. And this electron chlorine will accept. Here this electron will come. Giving the electron, sodium will form a positive ion. Chlorine accepting an electron will have a negative ion. So sodium ion plus chlorine ion forms the NaCl. It is electron transferring. What is the kind of the bond? Electron transfer. That means sodium donating the electron and chlorine accepting the electron. Donating and accepting. Electron transport. Through electron transport, sodium chloride, this is salt, is formed. How many bonds? Here there is only 1 bond. Now another example we will take is H2O. It is known as water. electronic configuration of hydrogen is 1 and oxygen is 8. So electronic configuration will be 2, 6. Now this is the hydrogen, it has 1 electron. Suppose oxygen is here, it has on the outermost shell how many electrons? 6 electrons. 2, 4, 2, 4, 6. And this is hydrogen. This is also has, it has also 1 electron. Now you see this hydrogen cannot donate 1 electron. To attain helium's electronic configuration it need 1 electron. But the oxygen cannot donate 1 electron to this hydrogen because it need 2, 4, 6. There are 2 electrons. Oxygen need to attain the electronic configuration of neon, its nearest inert gas. Helium atomic number 2, neon atomic number 10. Okay, so oxygen will give this electron to hydrogen to make a bone. This is one bone. This electron is shared with hydrogen. The oxygen share this electron with hydrogen and hydrogen is attaining the helium's electronic configuration. Now the oxygen will take these 2 electron from the 2 hydrogen atom like this. Now how many electrons on the outermost the oxygen have? 2, 4, 6, 8. 8 plus 2, 10. That means the electronic structure of neon it attains. So both are satisfied. That means oxygen and hydrogen are sharing their electrons and forms 2 bond. So here therefore it is written the valence electron determines the kind and number of bonds formed by the elements. I have discussed 2 types of bonds. One electron transferring and accepting, donating and accepting, and one electron sharing. This is the electron sharing. Trend in the modern periodic table. The valency of an element is determined by the number of valence electrons present in the outermost shell of its atom. The valency of an element is determined by the number of valence electrons present in the outermost shell on each atom. Yesterday I discussed these things. Atomic size. The term atomic size refers to the radius of an atom. The atomic size may be visualized as the distance between the center of the nucleus and the outermost shell of an isolated atom. The atomic radius of hydrogen atom is 37 picometer. 1 picometer is equal to 10 to the power minus 12 meter. 1 pm means picometer is equal to 10 to the power minus 12 meter. Atomic radius decreases in moving from left to right along a period. So remember this one. The atomic radius decreases in moving from left to right along a period. Note it down. This is due to an increase in nuclear charge which tends to pull the electrons closer to the nucleus and reduces the size of the atom. The atomic size increases down the group. This is because new cells are being added as we go down the groups. This increases the distance between the outermost electrons and the nucleus so that the atomic size increases in spite of the increase in nuclear charge. So, in case of a column or group, the atomic size increases down the group. That means from top to bottom, when you move, the atomic size increases downwards. And left to right, in case of periods, atomic radius decreases from left to right. Remember it. Metallic and non-metallic properties. The metals like sodium and magnesium are towards the left hand side of the periodic table, while the non-metals like sulfur and chlorine are found on the right hand side. In the middle, we have silicon, which is classified as a semi-metal or metalloid because it exhibits some properties of both metal and non-metal. This is very much important to understand. You please recall the periodic table, second period. Suppose second period. Here, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. On the third period, here sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. The atomic number of lithium is 3, 4, 5, 6, 7, 8, 9, and 10. Sodium 11, 12, 13, 14, 15, 16, 17, 18. What is told here? The metals like sodium and magnesium are towards the left hand side of the periodic table. Sodium, magnesium, aluminum on the left hand side. This is left hand side. Left hand side. This is right hand side. In the middle, silicon, these are non-metal. This is metal. And in the middle we have silicon, which is classified as semi-metal or metalloid because it exhibits some properties of both metal and non-metal. Now, in the middle, what is there? Silicon. The silicon is called metalloid. Silicon is called metalloid because it exhibit both the characteristic of metal and non-metal. Silicon possesses both the characteristics of metal and non-metal. It shows both characteristics. But towards the left side of the periodic table, sodium, magnesium, aluminum are metal, and on the right hand side, oxygen, fluorine, neon, sulfur, chlorine, all these are non-metal. In the middle, the metalloids are present. In the modern periodic table, a zigzag line separates metal from non-metals. The borderline elements boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are intermediate in properties and are called metalloids or semi-metals. So the whole periodic table I am not going to draw here. A zigzag line determines these are the elements. These possesses both metals and non-metals properties, and so they are called metalloids. Now, another important point, you note it down. Metallic character decreases across a period and increases down a group. The metallic properties decreases across a period and increases down a group. As the trends in the electronegativity show, non-metals are found on the right hand side of the periodic table towards the top. These trends also help us to predict the nature of oxides formed by the elements, because it is known to you that the oxides of metals are basic and the non-metals are acidic in general. So these are the properties of the elements changes on a period and group. So you learn it by heart and try to understand the chapter and learn the name of the elements, their atomic number and their valence electron and their valency also. So here I finish the chapter. Next day I will take another chapter. Till then, goodbye and good night.